Good morning to all. I am Rajitha, working as Assistant Professor of Artificial Intelligence and Data Science Department in SNS College of Engineering. Today, we're going to see about professional ethics subject. Let's move on to the subtopic that is engineers as responsible experimenter in professional ethics. Introduction. Engineering is a discipline that embodies creativity, innovation, and the application of scientific principles to solve complex problems. Engineers not only design and build systems, structures, and technologies, but also play a crucial role in experimenting with new ideas and process. However, the nature of experimentation in engineering brings with it a host of ethical considerations. Engineering must act as responsible experimenter, balancing technological advancement with ethical obligation to society, the environment, and the professions. The ethical landscape of engineering. Ethics is engineering is essential for maintaining public trust and ensuring the safety and well-being of society. Engineers are often at the forefront of developing technology that can have far-reaching impact, making their ethical responsibility all the more significant. Defining professional ethics. Professional ethics emphasizes the moral principles that guide engineers in their professional conduct. The includes honesty, integrity, accountability, and respect for human rights. Engineering societies such as the American Society of Civil Engineers and the Institute of Electrical and Electronic Engineer have established codes of ethics to guide members in the professional decision. The role of experimentation. Experimentation is fundamental to the engineering process, enabling innovation and the discovery of new solutions. However, experimentation must be conducted ethically, ensuring that potential risk are carefully assessed and communicated. Engineers must adapt a systematic approach to experimentation following established methodologies while remaining open to scrutiny and peer review. Safety and risk management. Safety is a paramount concern for engineers responsible. Experimentation involve rigorous testing and evaluation to identify and mitigate risk associated with new technologies. Engineers must prioritize public safety and adhere to industry standard regulation and best practices in conducting experiments. Transparency and honesty. Responsible engineers communicate their finding and methodology transparency. This includes sharing both success and failure, which foster trust among stakeholders. Falsifying data or omitting critical information and undetermined ethical standard and can lead to disastrous consequences. Social responsibilities. Engineers must consider the border of societal implication of their works. This includes evaluating how new technologies impact community, public health, and the environment. Engaging with stakeholders, including the public, can lead to more informed decision making and enhance the ethical dimension of engineering practice. Sustainability and environmental consideration. Responsible engineers try to develop sustainable solutions that minimize environmental impact. This involves evaluating the life cycle of materials and process, promoting renewable resource and reducing waste. Ethical experimentation includes assessing the environmental consequences of new technologies and striving to create systems that support ecological balances. Continuous learning and professional development. The rapidly evolving nature of technology requires engineers to commit to lifelong learning. This ensure that they stay informed about advancement in engineers practice and ethical standard. Engaging in professional development and continuing education helps engineers remain accountable to evolving ethical expectation. Challenges faced by engineers. Pressure to compromise ethics. Engineers often face pressure from employees or stakeholders to prioritize profits or deadlines over ethical consideration. This can lead to ethical dilemmas that challenge their integrity. Responsible engineers must have the courage to speak up and advocate for ethical practice even in challenging circumstances. Technological uncertainty. As technology evolves, the ethical implication of new innovations may not be immediately clear. Engineers must navigate this uncertainty and consider potential consequences. Experimentation in emerging fields such as artificial intelligence biotechnology presents unique ethical challenges that require careful consideration. Globalization and cultural sensitivity. Engineers often work in diverse environments necessitating an understanding of different cultural values and ethical norms. Global projects may encounter ethical dilemmas that differ from those in their home country. Responsible engineers must approach global projects with cultural sensitivity and respect for local custom and values. Public perception and trust. Public perception of engineering practice can significantly impact the profession. Engineers must work to build and maintain trust through ethical conduct and transparency. Engaging with the public and educating them about the benefits and risk of engineering project can foster trust and understanding. Technology and disruption. Rapid advancement in technology can outpace existing ethical framework, leaving engineers grappling with new ethical dilemmas. Responsible experimentation requires adaptability with and a willingness to revise ethical standards as needed. Engineers must collaborate with ethicists, policymakers, and the public to develop guidelines they address emerging ethical challenges. Best practices for responsible experimentation adhering to ethical codes. Engineers should familiarize themselves with and adhere to the ethical codes established by their professional organization. These codes provide a framework for ethical decision making and behavior. Regular training and workshops on ethical practice can reinforce the importance of ethical standard in engineering. Conducting thorough risk assessment. Before embarking on any experimental project, engineers should conduct comprehensive risk assessment to identify potential hazards and develop mitigation strategies. Involving interdisciplinary team in the assessment process can lead to more robust evaluation and diverse perspectives. Encouraging open dialogue. Fostering a culture of open dialogue within organization can help engineers feel comfortable discussing ethical concern and dilemmas. Regular meeting, ethics training and discussion forums can facilitate conversation about ethical challenges and promote responsible experimentation. Engaging stakeholders, involving the public in the engineers process can lead to more ethical outcomes. Engineers should seek input from diverse perspectives to ensure their works aligns with societal values. Public consultation, community forums, and stakeholder workshops can provide valuable insights and enhance ethical decision making. Promoting a culture of integrity. Organizations should cultivate a culture of integrity that prioritizes ethical behavior and accountability. Leaders play a crucial role in modern ethical behavior and supporting employees in ethical decision making. Recognizing and rewarding ethical behavior can reinforce the importance of ethics within the engineering professions. Conclusion. Engineers play a vital role in shaping the future through their innovating designs and experimentation. As responsible experimenter, they must navigate the complexity of ethical consideration, prioritizing safety, transparency, society responsibility, and sustainability by adhering to ethical codes, conducting thorough risk assessment and engaging stakeholder. Engineers can ensure their work align with the highest ethical standard. This commitment not only protect the public but also foster trust and respect for the engineering profession, ultimately leading to a more sustainable and equitable future. Case study of engineering and social experimentation. The development of the Boeing 737 MAX overview. The Boeing of 737 MAX case exemplifies the critical importance of ethical responsibility in engineering, particularly concerning safety and accountability. The development and subsequent crashes of the 737 MAX raised significant ethical questions about the engineering decision making process and the prioritization of safety over corporate interest. background of this moral. The Boeing 737 Max was designed as a more fuel efficient aircraft to compete with Airbus. However, the development process was marked by pressure to expedite production and minimize cost. Key ethical issues: safety issues, lack of transparency, regulatory oversight. Consequences is, there are three types of consequences: tragic accidents, legal and financial repercussions, change in industry practices. Conclusion: the Boeing 737 MAX case serves as a stark reminder of the importance of ethical responsibility in engineering. Engineering must prioritize safety, transparency, and accountability, ensuring that their work align with the highest ethical standard. By fostering a culture of integrity and open communication, the engineering profession can work towards preventing similar tragedies in the future. Thank you.